Hello my dear children of class 12 science. We just do continue with the chapter that is mass energy equivalence. This is one of the second last chapter that we were discussing in the last class also, and today we just wind up this chapter by solving three numerical problems. So we solve only three numerical problems, okay, from this chapter mass energy equivalence, and we move to next chapter, the last chapter under unit number 8. Nuclear fission and nuclear fusion. Okay, now we start with problem number 1. Problem number 1 says that calculate the first part, mass defect of helium He2 nucleus. So we need to calculate the mass defect of helium He2 nucleus. And second part, its binding energy. We need to calculate binding energy in mega electron volt. So mass defect we need to calculate. Then after that we calculate the what? Binding energy. Mass of proton is given 1.007276 U means unified atomic mass unit. Mass of neutron is given 1.008665 U means unified atomic mass unit. And even the mass of helium nucleus He2 is given 4.001506 U. Now this is one of the question came in ISC 2016. Okay, so let's try to solve this problem. So let's do the solution of this question. So in this question we are dealing with which nucleus? Helium nucleus. This is for helium nucleus, and it is how much? He24. So this is for helium nucleus. Okay. Now for helium nucleus, what is given? The mass of proton is given. Okay, but in this helium nucleus, if you see, this Z2 is actually the atomic number. This 2 is called what number? Atomic number. And we mark the letter what? Z. And Z equals to 2. Now, what is the mass number? This number is a mass number. So, mass number, and we know mass number is symbolized by A, and that is 4. So, if mass number is 4 and atomic number is 2, then we can calculate the what? Number of neutrons. The number of what? Neutrons. And the number of neutrons is nothing but mass number minus atomic number. Okay, we calculate by mass number minus atomic number, which is 4 minus 2 means what? 2. Okay, now in this question, your mass of proton, mass of neutron, the mass of helium nucleus is given. Okay, so which means we can calculate the mass defect of helium nucleus. Now we can directly use the formula, and the formula is the mass defect of He2 nucleus, that is called helium nucleus, is given by delta M, and delta M, the formula is what? Z MP plus A minus Z Mn minus M capital N. So this is the formula that you have learnt. Now Z is the atomic number, and MP actually is the mass of proton, one proton, each proton, plus A minus Z means this number of neutron, Mn means the mass of neutron which is known, minus M capital N means the mass of nucleus. But which nucleus? This is for helium nucleus. Okay, so this is for helium nucleus. So let me just continue out here with the formula Z Mp plus A minus Z Mn minus, now Mn capital N I write down the mass of what? Helium nucleus. This is Mn, but for which nucleus? Helium nucleus, He2. So I can write this way also. Okay, so let's substitute the value. The value is Z is how much? The value of Z is how much? 2. So I multiply by 2. So 2 into what? Mass of proton. The mass of proton is 1.007276 U, plus A minus Z is also calculated. Number of neutron is also 2. Okay, 2 into the mass of neutron. So what is the mass of neutron? Yes, 1.008665 U, and minus the mass of helium nucleus. Yes, this is the mass of helium nucleus that we substitute, which is minus 4.001506 U. Okay, so this value is this much. Okay, this Mn is this much, and this mass of helium nucleus is this much. Now we can simply multiply this value. The 2 into 1.007276 U means, if you calculate with the help of calculator, you get 2.01455 2U. So this is the multiplication of these two quantities. Plus, now even if you multiply this 2 into this mass of neutron, it will be how much? 2.017, okay, 33 and U, okay, and minus lastly this mass of helium nucleus, which is already there, 4.001506 what U. Now we can add these two masses. Okay, so if you add these two masses, you will get approximately 4.0318882U. So check, you can add with the help of calculator. So 4.0318882U, U means the atomic mass unit, minus 4.001506U. Now finally we can subtract these two masses also, that give you the mass defect. So mass defect delta M equals to, now if you subtract these two masses with the help of calculator, you get 0.030376U. So finally the answer is, the mass defect of this helium nucleus is 0.030376U, a unified atomic mass unit. Okay, now after calculating this mass defect, we can now even calculate the second part, that is his binding energy. But we remember, children, this part, the binding energy should always be calculated in what? Mega electron volt. Okay, so the order of measuring binding energy is what? Mega electron volt. Now how to measure binding energy? Now, for measuring binding energy, you know there is a formula. The binding energy, binding what? Energy, and we mark by letter BE, is always delta M into what? C square. Mass defect multiplied by the speed of light, that measures the binding energy. But using this relation, I need to calculate binding energy directly mega electron volt. Okay, and there is a relation, children, you know that 1U atomic mass unit into C square, if you measure, it is equals to 931.5 mega electron volt. So it means if your mass defect is 1 unit, unified atomic mass unit, if you multiply C square, your binding energy will directly, how much? 931.5 mega electron volt. We have done this calculation in the previous chapter also. Now see what I do, your mass defect this much, so I multiply by 931.5 mega electron volt, that is the binding energy we measure in mega electron volt. So we already calculate mass defect. Now this energy, binding energy, is for one unified atomic mass unit, mass defect. But we have mass defect this much. To calculate in binding energy per mega electron volt, binding energy in mega electron volt, we need to multiply by this quantity. So write down, therefore BE is equals to 0.030376. Okay, if you multiply by how much? 931.5 mega electron volt, that measures the binding energy directly in what? Mega electron volt. So you can use the calculator and do the calculation. I write this answer in one decimal place, which is 28.3 mega electron volt. So if I round up and write the value, your binding energy will be how much? 28.3 mega electron volt. So the final answer is, the binding energy of its helium nucleus is 28.3, and the unit is what? Mega electron volt. So this is one of the first problem under mass defect and binding energy. Now we will be solving next number, now problem number 2. Now we will be solving problem number 2, as I said, and problem number 2 said that determine the binding energy per nucleons. Now determine the binding energy per nucleon means binding energy divided by the number of nucleons, and number of nucleons also called what? Number, mass number. But of the nucleus of which atom? Oxygen atom, O816 atom. One of the stable atom of oxygen, that is O816 atom. Okay. Now given the mass of a hydrogen atom, the mass of hydrogen atom is called mass of proton also. Okay, that is 1.00782 U. U means atomic mass unit. Since the mass of neutron is given, 1 neutron, 1.00866 U, and lastly it is also given the atomic mass. The atomic mass is also given. The atomic mass of O816 is 15.994915 U. Okay, so in order to calculate the binding energy per nucleons, first of all we calculate the binding energy of this oxygen nucleus. But we calculate this binding energy in terms of what? The atomic mass. Because your mass of nucleus, oxygen nucleus, is not given. So what is known? Atomic mass is known. That's why there are another formula. This another formula that we can use for measuring the atomic mass of binding energy of this nucleus. Okay, so let's do the solution of this question. Now I do direct formula. I calculate directly. Okay, and the formula is binding energy, as you know, equals to mass defect into c square. As you know that binding energy B equals to mass defect, delta M is mass defect into c square. But what is the formula of mass defect out there? The formula of mass defect is ZMH plus A minus ZMN minus MXZ what? A with bracket with c square. So ZMH, MH means the mass of hydrogen atom, plus A minus Z, Mn means the mass of neutron, minus MXZA. This is the formula. This is the atomic mass of the element. But we are taking which element? Oxygen element. So let me just write down again. ZMH plus A minus Z, Mn minus M. Okay, let me write this is O816. No, this is the atomic mass of oxygen atom. So this is the formula. So I replace this XZA by O816. Okay. Now in the question, now we are dealing with what? Oxygen atom. Now you know for oxygen O8 at 16 atom, if you see, okay, 8 is the what? Atomic number. 8 is the atomic number, and Z is the atomic number, which is 8, and this 16 is the mass number, which is symbolized by the A. So mass number is A, which is 16, atomic number is Z, which is 8. Now from here I calculate the what? Number of neutrons also. I calculate number of what? Neutrons. Okay, and the number of neutrons is given by what? A minus Z. A minus Z means 16 minus 8, which is 8. So we calculated A minus Z also in the relation. We know Z, and we know this mass of atom, where MH and Mn are the mass of hydrogen atom and mass of neutron. Okay, so let me now just substitute the value. Now Be equals to, the formula is ZMH plus A minus Z Mn minus M O816 atom into what? C square. Okay, now in order to solve this problem, so let me just put the value. Z is how much? 8 into MH. MH means the mass of oxygen atom is how much? A hydrogen atom is how much? 1.007825 U. Okay, plus A minus Z means also what? 8 into mass of neutron is how much? 1 neutron is given here. The value is how much? 1.00865 U minus, now atomic mass of oxygen is how much? Atomic mass of oxygen this much, which is 15.994915 U. Okay, into what? C square. Into what? C square. Now these two, if I multiply, you get approximately 8.0624 U, plus if I multiply these two, okay, with help of calculator we get 8.06932 U minus, this is how much? 15.994915 U. Okay, with the square C square. Now I add these two quantities. So these two quantities, if you add with the help of calculator, we get approximately 16.13192 U. Just you can check it out and add it, you get approximately this much value. Minus, there's already 15.994915 U. And we multiply whole bracket into C square. Now let's take the difference of these two quantities. If you subtract these two quantities, then you get approximately 0.137005 U into C square. Okay, now this is the mass defect multiplied by C square. But you know, when we calculate binding energy directly in mega electron volt, we multiply by that amount corresponding to mass defect one unified atom mass unit. Okay, so and the quantity is 0.137005. I need to multiply with 931.5 mega electron volt. And children, in this type of problem will come in the examination. In the question paper only, the value that how much value of binding energy that you need to multiply corresponding to one atomic mass unit, that will be given to you. That's why sometime you will be given 931 mega electron volt only. If it is given 931 mega electron volt, multiply by 931 mega electron volt. If it is given 931.5 mega electron volt, multiply by that value only. So we are using this value now. If you multiply these two quantity, you get 127.6 mega electron volt. So what is this? This is the binding energy of this nucleons, binding energy of the nucleus of oxygen O8 16 atom. But actually we need to find what? Binding energy per nucleus. And you know, binding energy per nucleus means binding energy divided by number of nucleons. And that is also divided by what? Mass number. Now let's substitute the value. So binding energy per nucleons of this O8 16 oxygen atom is goes to binding energy 127.6 mega electron volt. Now we divide by the mass number, that is also the total number of nucleons. And for oxygen atom, what is the mass number? Yes, 16. So we divide by 16. So if you divide, you get approximately 7.975 mega electron volt. So you can see now the value of binding energy per nucleons of oxygen atom, 7.975 mega electron volt. And tell you that this binding energy per nucleon value is usually high, okay, as compared to other atom. That's why this oxygen atom, O8 16 atom, is one of the stable atom of oxygen, okay, atom of the element. So this is one of the numerical based on the binding energy per nucleons. Now we will solve only one numerical now, and with that numerical the chapter completed, and that you will learn in the next YouTube video.